The question says four equal masses m each is placed at the corners of a square of length L as shown in the figure. The moment of inertia of the system about an axis passing through A and parallel to dB would be. So let's analyze this question a little bit. Now there are four masses of mass m placed on the corners of a square. And what the question is saying, how the axis is going, passing through A and parallel to dB. So the axis would be something like this. This is parallel to dB and passing through it. So let's find out the moment of inertia. Now on this axis, A is on the axis, it won't create any moment of inertia. So moment of inertia due to A would be equal to 0. D would create it, C would create it, and so would B. So let's find out moment of inertia due to individual particles and add them up. So this is what the question figure would look something like. So wherein this length of particle B and D from this axis is D and AC is the diagonal. So we know that diagonal of a square is whose length is L is equal to L root 2, and this D is half of the diagonal of the length L. So L root 2 upon 2, that is equal to L upon root 2. So we have the distance AC and the distance D. So we can find out the moment of inertia by adding the inertias individually of the particle. So moment of inertia will be equal to m0 square. This is due to particle A which lies on the axis. Therefore its moment of inertia will be equal to 0 plus md square due to particle B plus md square due to particle D plus m AC square due to particle C. So I will be equal to 0 plus ml by root 2 whole square plus ml by root 2 whole square plus m root 2l whole square. So I will now be equal to ml square by 2 plus ml square by 2 plus 2 ml square. Therefore moment of inertia equals to 3 ml square.